Looking at section 4.2, trigonometric functions, the unit circle. So some of this should be some good review of the trig class you took last year. Some of it may be adding on some new pieces. So we're going to look at use a unit circle to define trigonometric functions of real numbers, recognize the domain and range of sine and cosine functions, find exact values of the trigonometric functions at pi over 4, use even and odd trigonometric functions, recognize and use fundamental identities, use periodic properties, and evaluate trigonometric functions with a calculator. So some of this stuff, as I said, should be good review, but it's always good to have that refresher. So our unit circle is a circle of radius 1 with its center at the origin of a rectangular coordinate system. The equation of this circle is x squared plus y squared is equal to r squared. That's your basic equation of a circle. So we're in our xy coordinate plane. They're telling us that that radius is 1 unit. So if you look down at that bottom equation, how they have that filled in, that would be an x squared plus y squared is equal to 1. Our radius of 1 squared, gives us that value of 1. We are over a distance of 1, and then we are rotating, as we looked at in the last section, counterclockwise to look at a positive angle. So some more information in a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. So we know that whatever the central angle is here is going to be equal to the distance along that piece of the circle. It says both are given the same real number t. The 6 trigonometric functions, we have our sine, our cosine, and our tangent, and our abbreviations for those. Our cosecant, our secant, and our cotangent. Again, this should be some review stuff, not the first time we've seen these 6 trigonometric functions and their names. Some definitions of the trigonometric functions in terms of a unit circle. It says if t is a real number and p is equal to xy is a point on the unit circle that corresponds to t, then we know that sine of t is going to equal y. Well, what does that mean in terms of our coordinate plane? When we take that positive angle, right, we have our terminal angle. If I were to take and draw in some sort of point, which would be an xy point, which would be the radius of our circle, that would give us this point xy. They say that the sine of t is equal to y. So whatever that y value is going to be whatever the sine of that angle t is going to be. The cosine of t is going to be that x value, and the tangent of t is going to be the y over x. And if you kind of know a little bit more about our good old friend SOHCAHTOA, your sine is your opposite over hypotenuse. Your cosine is your adjacent over hypotenuse, if I can put a capital A correctly, adjacent over hypotenuse, and your tangent is your opposite over adjacent. You have the sine is going to be the side that's opposite, which is going to be that the distance going up and down, which is your y value, compared to your hypotenuse, which if we have a radius of 1, that's why it's just equal to y. The cosine would end up being the adjacent side, which is what is right next to it. That is going to be the x value, how far you go over to the right, divided by that hypotenuse, which is a 1, which is why it's just an x. And your tangent is that opposite over adjacent, so your opposite value y over your adjacent x. They also remind you x cannot be equal to 0 because then you'd have an undefined value. Our cosecant is going to end up just being the reciprocal, right? That's all that these are, the reciprocal. So if we have the sine of t is equal to y, the cosecant of t is going to be the reciprocal 1 over y, as long as y is not equal to 0, because again, that would cause an undefined value. Our cosine of t, take the reciprocal, we get our secant, 1 over x, x cannot be equal to 0. And then our tangent of t, y over x, becomes our x over y. So all those are those reciprocal functions. It's just flipping the fraction. Again, stuff you should already know. All right, so an example, finding values of the trigonometric functions. It says to use the figure to find the values of the trigonometric functions at t. So we have our sine of t. So if we're looking at the values we have along our point, they tell us point P, we have an x value and we have a y value. That means in regards to our sine of t is just going to be whatever that y value is, which is going to end up being a 1/2. Remember, that's our y value. if we're dealing with sine. Cosine means that we're dealing with our x value. Our x value tells us that we have a square root of 3 over 2. And then our tangent is the same thing as our y divided by x, which means that we are taking our y value of 1/2 and dividing it by that root 3 over 2. Well, dividing fractions, that really means we have a 1/2 that's being divided by root 3 over 2, which means we have a 1/2 that's going to multiply by 2 over root 3, just basic division of fractions multiplied by the reciprocal. If we simplify that down, the 2's cancel. We're left with 1 over root 3, which at this point we know we cannot have a radical as a denominator. So we're going to rationalize our denominator by multiplying by, I don't want a 2 there. I want that to be a 3. I would need a root 3 over root 3 to give us a root 3 over 3. Again, you should kind of remember how to rationalize the denominator at that point too. The next part asks for the cosecant of t, the secant of t, and the cotangent of t. And we know those are just the reciprocal functions. So if I go back up here, if I have a sine of t is 1/2, that means I'm going to have a cosecant of, flip the fraction, we're going to have a 2. If I have the secant of t, again, I'm going to come back up here, I have a root 3 over 2, which means I'm just going to flip it and call it a 2 over root 3. Whoa, too fast. 2 over root 3, which again, we talked about having to rationalize that denominator. So multiply by root 3 over root 3. So we have our 2 root 3 over 3. And then our cotangent of t is just the reciprocal. Well, I'm going to go back over here and look at it from the point of, I have this 1 over root 3. So when I take and I flip that, that's just going to give me a root 3. If I had taken my simplified answer, I'd have to undo all that work that I did with rationalizing that denominator. So what happens with domain and range of a sine and cosine function? Well, in general, you should kind of have a brief understanding of what sine is doing. Sine is going to end up making that sine wave that goes from left to right like this, right, along a graph. The value of our domain, it's going to continue going to the negative infinities and the positive infinities. I drew this really terribly, but that's okay. You guys kind of get the idea. The highest value it's going to hit is going to be a positive 1, and the lowest value it's going to hit is a negative 1, unless there was a transformation of that sine function. So it tells us that the domain of the sine function and the cosine function is negative infinity to positive infinity. I can continue off to the left and continue off to the right with my sine and my cosine. It says the set of all real numbers. It says the range of the function is -1 to +1. It says the set of all real numbers from -1 to 1 inclusive. The highest value it can go to is equal to 1, and the lowest value it can go to is equal to -1. Some exact values of trigonometric functions at t is equal to pi over 4. Pi over 4 is probably the easiest trigonometric function to find, or the easiest angle to find, because pi over 4, if you think about when we talked last time about halfway around, gives you pi, which means we had a pi over 2, which means we'd have a pi over 4, which is a 45-degree angle. It's kind of a nice angle to look at in that sense. So it says that trigonometric functions at t is equal to pi over 4 occur frequently. We use the unit circle to find values of the trigonometric functions at t equals pi over 4. It says we see that point P is equal to AB. So if you look over at the little circle, we have this dot here, this point right here. That point P is equal to AB. And it tells us that that lies on the line y equals x, basic linear function. Y is equal to x. It goes through the origin. It goes up 1 over 1, up 1 over 1, up 1 over 1, which means that A and B are going to be equal to each other. So it says, thus point P has equal x and y coordinates, meaning that A is equal to B. Finding some exact values of the trigonometric functions at that t equals pi over 4, it says that we can find the coordinates as followed. So if x squared plus y squared is equal to 1, our basic foundation of a circle, we have a radius of 1, that's y is equal to 1. And we know that point P, which is AB, lies on that unit circle. So we'd have a squared plus b squared is equal to 1. But because we know that a and b are going to equal each other, instead of having a b squared here, we can replace that with an a squared because it's the same value, which means that we have a 2a squared, which equals 1. If If we divide it by 2, and then we take the square root, we'd have a is equal to the square root of 1/2. Well, we know that a square root of 1/2 is not a simplified form. I'm going to use the space up here. If I have a square root of 1/2, that means I have a square root of 1 over square root of 2, which means I'd have to rationalize my denominator, which means I'm going to end up with a square root of 2 over 2. So there they had said because a was greater than 0, we only took the positive square root of the both sides. So continuing with finding those exact values, so we have used the unit circle to find the coordinates of point P, which is AB, that corresponds to t is equal to pi over 4. We found that root 2 over 2, and since A and B are the same values, that's what our ordered pair is going to be. It's a root 2 over 2 for both x and for y when we have this pi over 4 as our central angle, and we have radius 1. So looking at finding values of those trigonometric functions at t is equal to pi over 4, we're going to start with finding the cosecant. So the cosecant means that we are dealing with the reciprocal of our sine function, right? We're really dealing with a 1 over the y value. A 1 over the y value means that we're going to have a 1 divided by that root 2 over 2, which means we have 1 divided by root 2 over 2, or 1 times 2 over root 2. So if I have a 2 over root 2, we can rationalize that denominator by multiplying by root 2 over root 2, which is going to end up giving us a 2 root 2 divided by 2, which gives us a final answer of a square root of 2. So in some cases, these are going to be quick and easy. You're going to be able to look at them and identify them because you've had practice last year. But for those of us that need to go through the actual math of it, there you go. The other one gives us the secant of pi over 4. So if we're finding the secant, that means that we are looking for our reciprocal of our cosine function. So that means we're really trying to figure out what 1 over x is. Well, that's going to be a 1 over root 2 over 2, which we just did all that crazy work, so I'm not going to do it again. What do we end up with then? We just end up with a square root of 2. Now, if I were to go and find my cotangent is going to end up being my x over y. Tangent is y over x, so cotangent is x over y. So if I have an x over y, that means I have a root 2 over 2 divided by a root 2 over 2. And anything divided by itself is going to end up equaling 1. So our trigonometric functions at pi over 4, they give all of them to us here. Our sine of pi over 4 is a root 2 over 2. The cosine of pi over 4 is a root 2 over 2. The tangent is 1, because if you're taking sine divided by cosine, you get 1. Our cosecant is going to be a root 2. Our secant is going to be a root 2. And if you took a root 2 divided by a root 2, you'd have our cotangent at, again, a positive 1. So talking about some even and odd trigonometric functions, it tells us that the cosine and the secant functions are even. If you remember back to some of the work we've already done this year with our even and our odd functions, if you remember even functions, they meant that f of t is equal to f of negative t, right? The original function is the same thing as the opposite value plugged in. Our odd functions came when we had that f of negative t was equal to the opposite of our function f of t. So it tells us that the cosine and the secant functions are even, meaning if I take the cosine of a negative t, it's the same thing as taking the cosine of positive t. If I take the secant of negative t, I have the secant of just t. And if you think about it in general, if I were to talk about my angle, right? Whatever point is up here is also going to be the same thing as the point down here. Our x value, whatever that distance across is going to be the same thing above and below. The x value is the same thing, whether you went to the positive angle or to the negative angle, which is why these are going to be equal to each other, because that x value is the same whether you went up or you went down. The next one talks about the sine, cosecant, tangent, and cotangent functions are odd. So it says sine of negative t is equal to the opposite of sine of t. The tangent of negative t is equal to the opposite of the tangent of t. The cosecant of negative t is the opposite of the cosecant of t, and the cotangent of negative t is equal to the opposite of the cotangent of t. So these ones here, those negative signs end up becoming the opposite of those values. And if you think about it, our sine value is always going to talk about that y value. Well, if our y value going up is positive, our y value going down is negative, that's why we have that opposite happening on the outside of these. And the tangent functions, the reason why those are also falling in that category of being odd is because as soon as you throw that sign in there as a negative, it makes the whole value negative. I'm not going to go through that. That was just an extra blurb I had, but I already drew it out for you. All right, so an example, using even and odd functions to find values of trigonometric functions. So it says to find the value of each trigonometric function. We have secant of negative pi over 4. Well, if I have the secant of the negative, that means that I'm just going to have the secant of the positive, right? Because if I have the negative on the inside, I can see it's the exact same thing as the positive, which means that we would have had that reciprocal function. We'd have that 1 over x, which means we would have had a 2 over root 2. And we went through that whole process of rationalizing the denominator. We'd end up with just that root 2. If I take the sine of negative pi over 4, that's where we're going to have the opposite of sine of pi over 4. And if I have the opposite of sine of pi over 4, that means that my answer is going to end up being a negative root 2 over 2 because our sine function is just that y value. That y value is a root 2 over 2, but we now have the opposite, so we have the negative value of it. So some fundamental identities. The reciprocal identities, right? Sine of t is equal to 1 over cosecant of t. The cosine of t is equal to 1 over the secant of t. The tangent is equal to 1 over the cotangent. These were reciprocal functions, right? Take the fraction and flip it. And vice versa. So you have your cosecant of t is 1 over sine of t. The secant of t is 1 over the cosine of t. And the cotangent of t is equal to 1 over the tangent of t. Now your quotient identities, when you have those divisions. Now we know that tangent of t is equal to the sine of t divided by the cosine of t. And our cotangent is our cosine divided by sine. Those are reciprocals. If you remember our tangent of t, tangent was the same thing as like the y divided by the x value. And we know that sine talks about y and cosine talks about x. So an example on that. Using quotient and reciprocal identities. So it says given the sine of t is 2/3 and the cosine of t is root 5 over 3, find the value of each of the 4 remaining trigonometric functions. So if I have a tangent of t, tangent means I'm taking my sine of t divided by my cosine of t. Well, if my sine is 2/3, I'm dividing that by root 5 over 3. So again, some fraction division. So 2/3 divided by root 5 over 3, which means we have 2/3 multiplied with 3 over root 5. And the more you do this, the easier it gets, right? The 3's cancel. We end up with a 2 over root 5. Rationalize that denominator, root 5 over root 5, which is going to give us a 2 root 5 over 5. If I find the cosecant of t, the cosecant of t means that I'm dealing with my 1 over my sine value, or I'm dealing with the reciprocal of my sine value. So if you went with the 1 over sine of t, it will have 1 divided by that 2/3, which means you have 1 divided by 2/3, which means you have 1 times 3 over 2, which gives you a 3 over 2. That's what I was kind of saying. If you remember that this is a reciprocal function, it's the reciprocal of the sine, which means you could have just taken that 2/3 and flipped it to get that value. If we were to find our secant of t, now our secant of t means that we're dealing with our 1 over cosine, or the reciprocal of the cosine function, right? So if I have a root 5 over 3, I'm going to have a 1 over, the root 5 over 3, or just the reciprocal, which is a 3 over root 5. Rationalize that denominator, which means we have a 3 root 5 over 5. And if I have the cotangent of t, that means that I'm dealing with my reciprocal of my tangent, which means I'm dealing with my cosine of t divided by my sine of t. which means that I have my cosine root 5 over 3 divided by my 2/3. Root 5 over 3 times the 2/3, divided by the 2/3, gives us root 5 over 3 times the 3 over 2. All right, as I said, the more you do it, the easier it gets. We end up with a root 5 over 2 for that final answer.